Hello friends, welcome to my channel. Today we will discuss about L in solid. If you are new and want to learn what is S and O in solid, you can refer to my previous video. Today in this particular video, we will discuss about Liskov substitution principle and some key points about Liskov substitution principle. Then we will go through the sample example and apply Liskov substitution principle to it. Let's discuss about Liskov substitution principle. What is Liskov substitution principle and what are the key points? So, Liskov substitution principle is one of the 5 solid principles of object-oriented programming. It was introduced by Barbara Liskov in 1987 and is named after her. The principle is set of guidelines that helps in designing maintainable, flexible and robust software system. The formal definition of Liskov substitution principle says, let Q of type X is a property provable about object X of type T, then Q of Y should be provable for objects Y of type S, where S is a subtype of T. So, it is little bit confusing. This means that object of a superclass should be replaceable with objects of its subclasses without affecting the correctness of the program. In other words, a subclass should be able to substitute its superclass without altering it or without changing the existing properties of the system. Next, we'll discuss about the key points of Liskov substitution principle. What are the key points? The first key point is behavior preservation. What does it mean? Let's say any operation available on the base class should also be valid for derived class, and the derived class should not alter or remove the behavior defined in base class. Next key point, inheritance and subtyping. Liskov substitution principle is closely related to inheritance and subtyping. What inheritance does? Inheritance allows us to define a hierarchy of classes, and subtyping enable us to use the derived class in place of their base classes. Liskov substitution principle ensures that the substitution does not introduce unexpected side effects. Next key point is design by contract. What does it mean? Design by contract involve defining set of preconditions and post conditions for methods or functions. For example, when a subclass is overridden, it should not be weaken the precondition or strengthen the post condition of the base class. Next, exceptions to the rule. What does it mean? In certain scenarios, it might not be feasible to fully adhere to Liskov substitution principle, such as when we are dealing with hardware interactions, external dependency, or performance optimization. However, in such exceptions, it should be well documented and carefully justified. Next, we will discuss what are the benefits of Liskov substitution principle. First benefit is code reusability. Liskov substitution principle promotes code reuse, as derived class can be used interchangeably with their base classes. This allows for more modular and maintainable code. Next, flexibility and extensibility. By using Liskov substitution principle, the system becomes more flexible and make it easier to extend and evolve with new classes and features. LSP simplifies testing. Since derived classes adhere to the same interface and behavior as the base class, testing becomes more straightforward and predictable. Next, behavioral consistency. LSP ensures that the client code can rely on the behavior defined in base class even when we are using the instance of derived class. Let's demonstrate the Liskov substitution principle with before and after example. We'll start with a class hierarchy that violates LSP and then refactor to adhere the principle. In this example, we have a class that is base class called animal, and we have a virtual method in base class that is make sound. And there are two subclasses. One is dog another one is bird. We have a duck class where we have a fetch method and make sound method, and in bird class we have a fly method. Now let's see how this violates Liskov substitution principle. In this animal trainer class, we have to perform two checks to determine which specific method, whether it is fly or fetch method, should be called based on the type of animal. This violates the Liskov substitution principle because we are not treating the animal and its subclasses as true substitute for each other. Instead of, we are checking their type and branching the behavior accordingly. So here we are checking the type. If animal is of type dog or whether this animal is of type bird, then we are branching the behavior. Let's refactor the class hierarchy to achieve Liskov substitution principle. First, we'll introduce an interface that declares the make sound method. So I'll create one interface here and I'll name it as iAnimal. And here I'll declare make sound method, that is string make sound, and I'll make this interface as public. Next, we'll inherit the interface in the base class as well as in subclass. To do that, I'll here inherit it from iAnimal. Next, I'll go to bird class. Here also, instead of animal, I'll inherit it from the interface, and instead of the overridden method, I'll make it as a normal method. And same thing I'll do in dog class, where I'll inherit it from the interface, and instead of overridden method, I'll make it a normal method. Now both dog and bird implemented the interface that we have introduced. Now let's see how it adhere Liskov substitution principle. To do that, we'll go to animal trainer class. Here we don't need these checks, we'll just remove these, and here instead of animal, I'll pass iAnimal as a parameter, and we are done with this animal trainer class. Now it is very clean, and now we do not have to check the type, and based on that we need to act. So we are just calling the make sound method. And here in the program.cs file, what I need to do is, instead of animal, I'll just use iAnimal. Now we can replace this class, this base class, with any of the subclasses. Now both subclass dog and bird can be seamlessly used in the place of base class animal. This demonstrates the better design that respect LSP. So overall, Liskov substitution principle encourages developers to design class hierarchy and interface in such a way that allow for seamless replacement of objects that promote a stronger relationship between the base and derived class. By following Liskov substitution principle, developers can create more maintainable and robust software systems that are easier to modify and extend. I am done with today's demo. If you like my video, please do not forget to subscribe and stay tuned for my upcoming video that will be I in Solid. Thank you.